Alex.
Fire.
The egg will go through.
The egg will go through. Egg will catch on
Into
fire.
that thing.
Into the flask. Okay.
Into the flask.
Okay. Other ideas?
You ever watch iCarly?
No, but you should. I watch iCarly Hershey.
Stay focused.
The main dude.
Okay, here we go. I'm gonna go then.
Yeah.
Everyone does have a prediction
That's
written
what
down
my
though.
drawing is. Nobody
That is really a good drawing. I'm very proud of you. Alright. I am gonna put a little bit of rubbing alcohol onto the cotton swab so that it burns for sure. So it doesn't go out.
One time in Spanish class, I made the perfect question.
You made the perfect question.
That was
See
awesome.
what I gotta deal with? Oh, you know.
It was crisp.
Okay, can everyone see? Austin, if you need to stand and move, feel free to move. Yeah, if you need to, guys. Just make sure you're not standing in front of somebody else.
That's so cool.
Okay.
Yeah.
Okay, so write down what happened for your observations. Observation, egg ended up in the flask, or egg moved. Egg moved in the flask. Write it down.
It's kind of a puppy.
It was kind of, yeah, you could also write down it was kind of like a pop sound. Oh, it's one of those things. Can you guys tell that I worked out this morning? I'm much more energetic today.
Miss Head, how do you get the egg out?
We're going to talk about that too. I'm so glad you asked. That's a great question.
You break the flask. Somebody's get it in.
Actually, I woke up at 4:45 to work out. Thank you very much.
Why don't you just do it at night? Who wants to get a
Do you ever see Ryland up there? Does he work out? Did he work
I
out?
went to title boxing this morning. I didn't
Oh.
Yeah.
I think he does good.
Okay, so here's the deal, and we're going to kind of walk through some behaviors of air right now, and those are the important things to understand. You don't need to draw this picture, but I'm going to have our conversation over here, and then I'll come back. Okay? Let's talk about when the flask was, here's our flaming cotton ball. Okay? So we have our flaming cotton ball inside of the flask. Tell me, what is happening to the air that's inside the flask? Dallas?
The air is like behind the fire and use it for fuel and it's fueling.
Just tell me in terms of temperature, what's happening to the air?
It's getting very
Yeah, it's getting hot, and we're gonna keep it simple. Okay? So the air inside is getting hot, or it's getting warm. Okay? In comparison to the outside air, the inside air is definitely hot. Okay? When I place the egg on top of the flask, what happened to my fire? Cole, what happened to the fire? Did you notice? Yeah, the fire went out, right? So if I eliminate my fire, what happens to all of these air molecules that were really hot? And by the way, we also need to have this discussion. What is the behavior of an air molecule when it's hot or warm? Hershey's doing this. It's very energetic, right? Because temperature is just an indication of how much energy something has. So if it's an air molecule and it has lots of energy and it's really, really hot, it's moving around and it needs more. Connor, what are you thinking? We'll get to that. We'll get to that.
I'd say.
Okay, so air molecules that are really warm, they move around a lot more. And if they're moving around a lot more, what do they need more of? They need more room, okay? They need more food. No,
Let's take this in there.
So they need more room, and so the air molecules start to leave the beaker, so on and so forth. So anyway, these air molecules move, and they start to expand because they're needing more space. When we talk about the flame going out, right? Fire goes out. Here is our flaming cotton ball. Fire goes out. So obviously when the fire goes out, what happens to the air? To the temperature? It cools off, right? So the important thing to know, and Brandon, I see you thinking it already, what do you know about air that is cooling down? What does it do? It contracts, right? Think about yourself on a cold day. Right? You're freezing, you're trying to kind of pull yourself together.
I do that often.
Connor?
Or like doors in the summer, like the doors in the summer. expand.
Yeah, doors in the summer. You're coming in through the garage and you slam the door behind you and all of a sudden it's open and you're like, dang. Because your house adjusts, it expands in the summer and it contracts in the winter. Same idea. Good. So cool
Your house is like
means
mansion in the summer, with a shack in the winter.
that the air molecules condense. Okay, so here's the kicker. If this air is cooling and the air molecules are condensing, what does that mean about pressure of the inside of the flask? What are those, if the air molecules are coming together, what does that do to the pressure that's inside the flask? Does it go up or go down? Oh, turn your ringer off.
It's this random person there is calling me from the door of Colorado.
Hello?
Talk about that with your pair share partner. Your question is, what happens to the pressure inside of this thing? Keeping in mind there's an egg that's sealing the top. What happens to the pressure once those air molecules start coming together? Is it higher or lower pressure? Talk about it for 45 seconds. Go. When air molecules are condensing,
I know.
That's only my soda.
there was like 400.
There's like 460 yesterday.
All right, your 45 seconds is up. What do you think? Somebody raise your hand and tell me what your group talked about. Does the pressure go up when things are condensing inside of this beaker, or does the pressure go down? Austin, what did you guys talk about? You and Kay, what did you decide? Either of you, because you were pair share partners, right? You're talking when I give you that time. Pressure goes up. Okay. Annie, what did you guys talk about? You and Jim. Pressure goes higher. Okay. Other ideas? You think it goes up? Okay. Oh wait, we said higher. Did anybody say the pressure was lower?
Yes.
You guys did?
Yes.
We did?
So here's maybe a drawing that will help us understand what's going on. The green air molecules are the air molecules that are really spread out and really excited. And I'm exaggerating this, okay? This is not at all a like to scale picture. So all of these air molecules are hot and they're excited and they're moving around and they're pushing on the beaker or on the flask. If I cool those air molecules, those are going to be the blue ones. If I cool those air molecules, are they as spread out as they are now?
They're more together.
They're more together because cool means condense. So let's say that those same air molecules come in a little bit more. Are they still able to push on the flask?
No.
Uh-uh. Because they're coming together. So you're actually, you have a lower pressure that's inside. You have